Okay, hello, my lovely grade 10s. This is Unit 2, Lesson 1, or 2.1, and Unit 2 is all about trigonometry. And essentially, trigonometry means triangles and angles and missing sides of triangles. And we're trying to calculate everything about a triangle that we don't know, essentially. Okay? We are going to have to use your scientific calculators today. So I highly, highly recommend that before you listen to this video, you go get your scientific calculator because we have to use the tan button today and you need to fiddle around with your calculator a little bit. All calculators are different. So I suggest you take your calculator out and do this each question along with me to figure out how your calculator works because they're all different. So it says here that we can use the sine, cos, and tan buttons on our scientific calculators to determine missing angles and missing sides in right triangles. So if you recall from, I think you learned this in grade 7, right triangles, or even before grade 7, right triangles are triangles that have a 90-degree angle in one of the corners. Okay, we call them right triangles or even rectangular triangles or 90-degree triangles, whatever. I usually call them right triangles. Okay, so it's the angle with 90 degrees there. For the purpose of this little diagram, I'm going to call this A, this B, and this 90-degree angle is going to be called C. So usually when we're dealing with triangles, that's how we name them. So I would call this triangle A, B, C. That's its title. It's the 3 letters being used to describe its angles, okay, or its corners or its vertices. In English, it's vertices, okay? This is called a vertex, the point right there, okay? But that's fancy. I'm just going to call them the corners or the angles, okay? So here I have 3 angles, A, B, C. Typically what we do, if we want to also label the sides, whatever the opposite angle is, okay, so the opposite angle to this side here is A. What we call this side n is also A, but lowercase a. Okay. So similarly, if I wanted to name this side, because it's opposite of angle B, I would call it lowercase b. And then finally, this side here that's opposite C would be lowercase c, but also this side is called the hypotenuse. The hypotenuse is always the side that's opposite of this 90-degree angle, okay? So there's something called a tangent property, okay? And this tangent property is going to help us figure out missing angles and missing sides in right triangles. And the tangent property goes like this. Oh my God. Tan of an angle. Okay, so for this specific example, I'll just use A. So say we're talking about tan of angle A. What we do is we're going to create what's called a ratio. A ratio is a really fancy way of saying a fraction. Okay, on the top of the fraction, I'm actually going to erase this. On the top of the fraction, we are going to write down the length of the side opposite of angle A. So that number will go up top. So whatever the length is of the side opposite of angle A. And then we're going to divide that by the length of the side adjacent of angle A. Okay, I know that kind of seems complicated. Okay, let's just break it down. Let's just make it a little bit simpler. So in other words, if I was creating this ratio in this example right here with this red triangle, on top, I'd have to put the length of the side opposite of angle A. So you would go back here and say, okay, which side is opposite of angle A? and it's that little a. So whatever number you see there, like when we actually get to examples, you might see like an actual 7 there or a 9 there. That's the number you put on the top of the fraction. Then on the bottom, you put the length of the side adjacent of angle A, or adjacent to angle A. Sorry, I'm kind of in French mode. In French, it's der, but to, adjacent to angle A. So adjacent is a really fancy way of saying beside. Okay, so if I want the length of the side beside angle A, so let's look at angle A here. Beside angle A, I have B, but I also have C. I kind of have two sides beside angle A, but you never choose the hypotenuse, okay? Hypotenuse is its own thing. If I want the hypotenuse, I would say I want the hypotenuse, but I don't say that. I say I want the adjacent side. So that's when you choose the other one. Okay, so you won't choose the hypotenuse. You would choose the other side in this case, which is B, and that goes on the other side, or on the bottom of the fraction. And then once you have those two numbers filled in this fraction, we use our scientific calculators, and it will pop out a number for us to find that missing angle. Okay, I'm just going to clean this up a little bit and get rid of some of this chicken scratch. There we go. And then on the bottom here should be B. Okay, so now we're going to actually get into an example using this ratio idea here. So example 1 says determine the tangent ratio, okay, so the ratio of the fraction, for both of the acute angles in the following triangles. So a little recap here of some grades 5, 6, 7 stuff. An acute angle is any angle less than 90 degrees, okay? And so if we have a triangle with a right angle in it, okay, the other two will always be acute angles, always. So I'll say that again. If you have a triangle with a right angle in it, the other two angles will for sure be acute angles, less than 90. So in this case here, we're going to determine the tangent ratios for both angle A and angle B. Okay, so I'm going to start with A just because it's alphabetical. So I'm going to start by finding the tangent ratio for angle A. So if I kind of abbreviate this, I know that this fraction up here said I want the length of the side opposite of A. So on side, up top, I'm going to put the side opposite of angle A. I'm going to divide it by the side adjacent to angle A. Okay, so now what we have to do is we have to go to angle A. And it's kind of like this is my eyeball. It's like I'm looking from A. There's my eyelashes. And on top, I want the side that's opposite on the total other side of the triangle. So that would be 3. So that goes on top. And then it says on the bottom, I want the side adjacent to angle A. So if we go back up to A, you can see there's two sides that are kind of adjacent to A or beside A. But again, we're not going to choose the 5 because that's the hypotenuse. And we don't want that one. I'm going to choose the 4. Honey, can you go back in your room? Elliot? 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 Hey, Elliot, can you go back in your room? That's a little bit loud, honey. Okay, one sec. Okay, sorry about that. So there, we figured out the ratio, 3/4. That's the ratio. That's where we're stopping. The question doesn't ask us to actually find the missing angle yet. We're just practicing finding the ratio. Now I have to do the same thing for tan of angle B, the other acute angle. So this one would be opposite still, but this time it's opposite of angle B because that's the angle we're talking about. Okay, so now for this question, B is my eyeball. So I'm going to go to angle B and I want to find the side opposite to B. So on the total other side of the triangle, that would be 4. Okay, then on the bottom, I want adjacent to B. So I look at the other two sides that are beside B, that's 3 and that's 5. But I'm not going to choose 5 because that's the hypotenuse, so it's 3. And boom, there's the ratio. So not so bad. Okay, we're going to do one more just to make sure we got it. So same thing here. I want to find the tan ratios for both acute angles in this triangle, A and B. I'll start with A just because it's alphabetical. Okay, and now for this question, I'm going to skip writing this out. Okay, I'm just going to go straight to it. So which side is opposite of angle A? Here's your angle A, opposite, boom, the 12. Okay, and then the adjacent here of the other two sides that are beside A, I have 13 and 5, but 13 is the hypotenuse since it's the side opposite that right angle. I'm not going to use that one. So there you go. There's your ratio. How easy is that? Let's do one more, tan of angle B this time because that's the other acute angle. So now you're looking from B. So the side opposite of B on the whole other side of the triangle is 5. And then again, the 13 is the hypotenuse, so we're not going to choose that one. So the adjacent one is the 12. Okay, so there's how you create ratios. Now we're going to get into actually using our calculators to find what the size of the angle is. Okay, so determine the size of angle A in each triangle. So we're only looking for, we're only looking for the size of that angle right there. So I know I have to set up my tangent ratio. So tan of angle A, so I know it's opposite over adjacent. So the side opposite of A here is 6, and the adjacent side out of the 8 and the 10 would be the 8, because the 10 is the hypotenuse. I don't want that one today, okay? So there's my ratio. So this is where it gets a little bit tricky on your calculators. If you're looking for an angle, which we are, like we're trying to find the size of an angle, okay, you have to actually find this button, tan -1. For me, my tan -1 button is actually just right above my tan button. So if you find your tan button, chances are right above it, you'll see tan to the -1. That's the button we want to access, is the tan -1, and that will help us find the angle. So on my calculator, I have to actually divide 6 by 8 first. So I'll show you exactly what my calculator does. I'm going to type in 6 divided by 8 equals. Okay, so I go 6 divided by 8 equals, and I get the decimal 0.75. Then to access my tan -1 button, I have to press second on my calculator. For you, it might be shift, okay, or even inverse. Some calculators have inverse. So second, shift, or inverse, and that button's usually on the top left-hand side of your calculator, but not always. So just look for it and find it. And then I'm going to press the tan button, and that will actually access the tan -1 right above it. By pressing second, it actually accesses the -1. Okay, so I go 6 divided by 8 equals, and I have 0.75 on my screen right now. And then I go second tan, and boom, the number pops up 36.9 degrees. And I rounded up there. You should get 36.86. I'll write that in just for, whoops. It's actually 36.8698, etc. Okay, and usually we actually round to the nearest whole degree. So 37 degrees is the closest whole degree. So that means that angle A is 37 degrees. Now, on some calculators, you actually have to do the opposite. Okay, so if that didn't work for you, this might work for you. So what you do is you press second and then tan, and then open bracket, 6 divided by 8, close bracket, equals. That might work for you. So on my calculator, I have to do the second and tan at the end, but some calculators make you punch it in first. Okay, so when you press second tan, you should see tan to the -1 pop up on your screen. Then you'll open the bracket, type in 6 divided by 8, close the bracket, equals, and it should spit out a 37. Those are the two most common ways to do it. If you're still not getting it, and you're determined to get it, and you're so confused and angry at your calculator, you could actually send me a picture of your calculator, and I'll take a look at it, and usually I can figure out what order you have to press your buttons in, and I'll figure it out for you. Okay. Okay. Also, I'll just mention one thing. You need your calculator to be in degrees. So if you look on your screen right now of your calculator, well, mine anyway says DEG at the top. That means I'm in the degree world, and that's what I want to be in. Okay, some calculators will say rad at the top, and you don't want to be in rad. That's called radians. That's for something else. So to get to degrees, most calculators actually have a button that says DRG. If you press on that, it actually changes what it says at the top. So if I keep pressing on my DRG button, it goes degree, then radians, then gradians, then it just switches that little word at the top, and I'm going to press it until I see DEG. You need to be in degrees. So that might be causing you a problem if you can't get the answer right. Okay, let's do another one. So I found my angle A there, it's 37, done. Over here, I'm finding this angle A now. So I'm going to create my ratio tan of angle A. Now, it's always the opposite on top. So opposite of angle A is the 7 divided by adjacent. Between the 5 and the 8.6, I know I'm going to choose the 5 because the 8.6 is the hypotenuse. I don't want that guy today. Okay, so again, on my calculator, I am going to first go 7 divided by 5 equals, and I get a decimal. I'll even say what the decimal is. 7 divided by 5 is 1.4. So that's what's on my screen right now, 1.4. Then I press second, and then I press tan, and I get 54.4623, etc. If we're rounding to the nearest degree, we would go down to 54. Okay, so all we do is look at this number. If it's 4 or below, we go down. If it's 5 or above, we go up. Okay, so angle A here equals 54 degrees. All right, the next set of examples is the opposite. It's where you're going to be given an angle and you have to find a missing side. Okay, so as you can see in this question here, example 3, determine the length of the missing side indicated in each triangle. So in this first triangle, I have this question mark right here. I want to find the length of that side, and I know that this angle is 30 and that this side is 11. So I have to use those two pieces of information to solve for that missing side. Okay, so we always start by setting up our tan ratio. Okay, now I am going to say tan of angle B because that's the angle I'm given. So the angle you always put here is your given angle. I'm not going to choose angle A because I don't know angle A. It won't help me. So you always put your given angle there, and then it'll be the opposite side of angle B over the adjacent side to angle B. Okay, so that's a setup we've been using normally. I just wanted to show you that we're going to choose B here because we know B. Okay, so I'm going to erase. Oh God, what did I just do? I'm going to just erase this, and we're going to actually fill in the values that we know. So tan of angle B would actually be tan of 30, right? I'm replacing angle B here with what angle B is, 30. So it's tan of 30 equals the opposite side of 30. So opposite is my unknown. So we usually indicate unknown by X. I'm looking for X, trying to solve for X. Then the underneath would be the side that's adjacent to 30, which is the 11. I know this side is also technically adjacent to 30, but that's the hypotenuse. So we don't want to use it, and we don't even know what that number is, so it wouldn't help us anyway. So there's the adjacent side. So there's my setup. Now your goal here is to solve for X. You're trying to figure out what is X. So I want to get rid of that 11. Okay, so by multiplying by 11 here, those would cancel out. But what I do to one side, I have to also do to the other side. So I'm going to multiply the left side by 11 as well. So now what this looks like is 11 times the tan of 30 I don't know why I just wrote it lowercase, will equal x. So we have to throw this in our calculator. This is actually easier. Whenever we're looking for a side, don't use the shift button, okay? We only use that second or that shift button, like I was talking about right here, when we're looking for an angle. We already have the angle here. We're looking for a side. So whenever you're looking for a side, all you do is punch in tan and 30, okay? On your calculator, you might have to go 30 and then tan. That's how my calculator works. If I want to figure out what the tan of 30 is, I type in 30 and then I press the tan button and it spits out a decimal. And the decimal here that I get for tan of 30 is 0.57735, etc., etc., etc. Okay, I'm going to leave that number on my calculator screen and then simply go times 11. And that equals 6.35. And I'm going to round that up. It's actually 6.35085. So I'll write those in. But I'm actually going to say it's just 6.4, and my unit is meters. As you can see here, 11 meters, and that is the length of the missing side. Honey, I just have one more example, okay? Can you wait 2 minutes? You can wait that long? Okay, thank you. Okay, so in this question here, we always start with the tan of the angle we are given, which is here, angle E. And then on top, I'm going to put the opposite of angle E, and then on the bottom, adjacent of angle E. So I'll just leave that up. So instead of writing angle E, well, I know what angle E is. It's 40. Plug it in. Now, the side opposite of angle E is the 9. And then the side, oh, I forgot. Yeah, sorry, I just had a, Elliot, I just had a brain fart. And then the side adjacent, so this one is the one I want to know. So that's my X, okay? So this is a little bit different because here the X is on the bottom, right? Here the X was on top, okay? When the X is on the bottom, there's actually something very simple that we can do to isolate X, and that is just flip-flop those two terms. So I can have X on the left side now, and then the tan of 40, I always am writing in lowercase for some reason, tan of 40 goes underneath. So those two guys just literally switch spots. So now on your calculator, you would have to go 9 divided by open brackets. And then for me, I have to go 40 tan. My calculator likes me putting the number in first, but you might be tan 40. It depends. But whatever you do, you have to go 9 divided by that. Okay, you can't type this in first. You have to type the 9 in first. So on my calculator, I go 9 divided by 40 tan equals 10.72578, etc., etc., and that rounds up to just 10.7, and the unit was centimeters. Okay, so be careful here. Again, I'm going to say when I go 9 divided by 40 tan, and I press just those buttons, so I press just 9 divided by 40 tan, it spits out a decimal, and that decimal is 0.83909, etc., etc. But that isn't your answer. That is what the 40 of tan is. So you have to press equals one more time to get the actual length of the side. Okay, like I said, on your calculator, you might have to flip those around and go 9 divided by tan of 40 instead. But whatever you do, put these in brackets on your calculator so it knows that you want to do tan of 40 and not tan of 9. So again, I know calculators can be complicated. So if you want to send me a picture of yours because you really can't figure it out, do so and I'll help you. Otherwise, I'll just help you in class when I see you next. Okay, here's your assignment. Okay, for this question right here, it talks about an incline. It asks you to find the angle that's, oh, I'm forgetting the English word. Inclinaison. Okay, whatever. It asks you to find the angle of incline. Okay, that's the angle opposite of the dotted line. Okay, so in every picture for number 10, you'll see kind of a dotted line. I want you to find the angle opposite of that dotted line. Okay, all right. Good luck with this. I know this seems a little bit like a completely different language, all this stuff, and it is. It's pretty tricky. It's pretty weird to wrap your head around. So please let me know if you have any questions. I have to go get my 4-year-old a snack or he's going to freak out. Okay, bye-bye.